Okay, hi guys, it's Mr. Brown here. Um, so I just wanted to go through these style of questions with you guys and just to give you a hand here. First thing, we're just going to read through it. So, a car moving at a velocity of 50 kilometers an hour east accelerates for 5.45 seconds at a rate of 2 meters per second east. What will be the car's final velocity? First thing I always do with these questions is check to see, do I have everything in my standard units, or my SI units. Um, One thing that jumps out at me right away is this kilometers an hour. Uh, that doesn't work. We need to get that into meters per second in order to actually work with these other two. So the way we do that, I'm just going to go through that first so we can just kind of tackle how to convert kilometers an hour to meters per second. So first thing I do is just write down 50 kilometers an hour. So 50.0 kilometers an hour. Okay, so now I want to get this into meters per second. So first thing I want to do, I'm going to get rid of the hours in the bottom. So I need to multiply it by something to get that out of there. So what I do is I have hours in the bottom on this side. So I'm going to put hours in the top on this side. Okay, and I want it to be in seconds. So what I'm doing is I'm saying for every 1 hour, how many seconds are in an hour? If you don't know, that's okay. The way that we can find out, though, is if you think about it, there are 60 seconds in 1 minute, and there are 60 minutes in an hour. So if we go 60 times 60, we have 3,600 seconds in an hour. So now that we have that, we've got hours over top of hours here. I can just cancel those out. I can say, well, I'm going to get rid of that and get rid of that. So good, I've gotten rid of hours. Now I have kilometers over top of seconds. So I'm halfway there. The next thing I need to do is get rid of this kilometers. So again, what I'm going to do is put the kilometers now. I'm going to put it on the bottom over here because it's on the top up here, and I'll be able to cancel them when we're done here. You'll see. Um, and I want it to be in meters, so I'm going to say, well, how many meters are in a kilometer? There are 1,000 meters in a kilometer. So now we can actually cancel those out too. So kilometers can go away. Kilometers and kilometers are gone. So now we're left with meters on the top here and seconds on the bottom there. That's perfect. That's exactly what we wanted. So we can rewrite this, just to make it a little bit less confusing, as 50, 50.0, and then 1,000's on the top here, 3,600's on the bottom, so I can just say 50, I'm going to multiply by 1,000 because it's on the top, meters, divided by 3,600. So that in meters per second is 13.9 meters per second. And there we go. We've figured out what this was in meters per second. So I'm just going to write it up here so we know we're dealing with meters per second. Okay, so that was step one. Now we can actually start to use these numbers in the question. So I'm just going to erase this stuff so we have some room. Okay, so the next thing I do is I make sure that I know exactly what we're dealing with in the question. So I just start going through the question. So it says, a car moving at a velocity of 13.9 meters per second accelerates for 5.45, yada yada. So this 13.9 meters per second, that's what it's traveling at to begin with. So that's my initial velocity. So I'm going to write that down. My initial velocity, VI, is equal to 13.9 meters per second. Okay, come down a little bit farther. Now it looks like my time is going to be equal to 5.45 seconds. And this next thing here, 2 meters per second, notice it says squared. As soon as I see that squared, I know we're talking about acceleration. So my acceleration is going to be equal to 2.00 meters per second squared. And what I should have done to begin with is write little arrows over top of these because they are vectors. I care about the direction. And they're going east, so they're both positive. So east and east. So that's positive for velocity. And my acceleration is positive too. Alright, so finally, what will the car's final, or what will be the car's final velocity? So we're looking for Vf. Okay, so really we can just go through our equations that we have there, and we can see that we don't have distance or displacement at all. So really there's only one equation on that list that we can even use to find our final velocity. And that's going to be this equation. It's going to be our acceleration is equal to change in velocity over change in time. And it's not quite looking exactly the same because there's this triangle or delta. This just means change in velocity. So what it's really saying there is acceleration is equal to my final velocity minus my initial velocity. That is change in velocity. And that's over change in time. I'm not going to get too worried about that because it says accelerates for 5.4 seconds. We're just going to say that that's our final velocity and our initial is 0. So really, it's just going to be over time, which is, let's call it t. Okay, so I'm going to rewrite this a little bit different so we can start to rearrange it. So really I'm saying this, acceleration is equal to Vf minus Vi over t. You guys have actually done this question already for me. Now we need to put it to use. So we want to get Vf on its own. That's what we're looking for, right? So remember, if it's on the bottom of one side of the equation, I can just move it up to the top of the other side of the equation. Really what I'm saying, remember, is that I'm saying we're multiplying both sides by time, but just for the sake of being easy, we're going to move it up to that side. So I'm just going to rewrite this. So I'm going to say acceleration times time is equal to final velocity, which we're looking for, minus our initial velocity. So we need to get rid of one more thing. It's minus Vi on this side. So all I'm going to do is go plus Vi minus Vi plus Vi. They equal 0, so I can just get rid of that. I plus it on this side, or I added it, sorry. I need to add Vi on this side. Alright, let's rewrite this again so we can kind of see what we have. So, acceleration times time plus our initial velocity is equal to Vf. Alright, notice that the final velocity is on the right side of the equation. That's fine. It's on its own. It doesn't matter if it's on the right side of the equation or the left side of the equation. That's good. So we can actually just start filling in numbers here. This is the easy part. So we know what our acceleration is. Our acceleration is positive 2 meters per second squared. Our time is 5.45 seconds. And we're going to add our Vi is positive 13.9 meters per second. And that's going to be equal to Vf. Okay, and if you put that into your calculator, just multiply this and add this, you're going to have Vf is equal to 24.8 meters per second. And make sure you notice that this is a positive 24.8 meters per second. That matters. That really means that this person is traveling 24.8 meters per second east. because east was the positive direction in our question. So there's my answer. Last thing I would like you to do on all questions, I'm just going to write it over here, is write out a sentence for me. So you're going to say, the question was, what will be the car's final velocity? Just write out the car's final velocity is 24.8 meters per second east. And I know it's east because it had a positive sign at the end. Okay, and that's how you do these style of questions. I'll have more to come.